Hello students, good morning. Hello everybody, welcome back to my class. This is Pradip Sir with another session of class 10 mathematics. Presently, we are doing the chapter Trigonometry from class 10 mathematics. In the previous class, I have shown you how to find the values of sin 30 degree, cos 30 degree and tan 30 degree, as well as sin 60 degree, cos 60 degree and tan 60 degrees geometrically. So here I am going to show you how to find the values of other standard angles like 0 degree, 45 degree and 90 degree for sin theta, cos theta and tan theta. Okay, means we will find the values of sin 0 degree, sin 45 degree and sin 90 degree. Similarly, we will find the values of cos 0, cos 45, cos 90, tan 0, tan 45 and tan 90 degrees. So first of all, let me start with 45 degrees. So in that case, we have to draw an isosceles right triangle. So triangle ABC is an isosceles right triangle where angle A is 90 degree and AB and AC are equal. Okay. Now, since it is isosceles triangle, then angle B and angle C are also equal and they are equals to 45 degree each. According to angle sum property of triangle, if these two angles are 90 degree, then the sum of these remaining two acute angles must be 90 degree, and since they are equal, so each angle is 45 degree. Okay. Now an altitude should be drawn. So this is altitude AP. Okay. Now let me take these two equal sides as A, length of each equal sides as A, and the base as B, the total length of the base as B. Now in case of isosceles triangle, if we draw the altitude, here AP is altitude, so if you draw the altitude, then the base is divided into two equal parts. The base BC is bisected. Okay, so therefore BP and PC are equal, so each is equals to B by 2. Understood? Okay. Now if we use Pythagoras theorem for triangle ABC, then we will find that AB square plus AC square is equals to BC square. The hypotenuse is BC, so it will be AB square plus AC square equal to BC square. Now AB is A, so A square, AC is also A, so this is also A square equals to BC square. So 2A square equals to BC square. Therefore BC is equals to root over 2A. So we have got the value of BC as root over 2A. So in place of B we can write root over 2A. Now the whole triangle side BC is bisected by the altitude AP. Therefore we can say that BP equals to PC equals to root 2A upon 2. BP equals to PC equals to root 2A upon 2, because both are divided into two equal parts. So each part will be A upon root 2. Okay. So each part will be, by cancelling, we got each part as A upon root 2. Okay. So this is A upon root 2. Now consider triangle APC. This is 45 degree. This is A, angle P is 90 degrees, and C is 45 degree. PC is A upon root 2. AP we have to calculate again by using Pythagoras theorem. AC is taken as A, so AP square plus PC square is equals to AC square. Using Pythagoras theorem, AP is not known, so AP will be AP. PC is A upon root 2, so A upon root 2 square, and AC is A square. Therefore AP square equals to AP square plus A square upon 2 is equals to A square. So AP square is equals to A square minus A square upon 2. That means AP square is equals to A square upon 2. So AP is equals to A upon root 2. So AP is also A upon root 2. Now just see one thing. If this angle is 45 degree, one of the angle of right triangle is 45 degree, this is already 90 degree, so this is also 45 degree. Okay, that is, these two angles are equal. Naturally AP and PC are also equal. PC and AP are also equal, and we can directly write AP as A upon root 2. So without doing this, we can simply use the property of isosceles triangle, that if two sides of a triangle are equal, if two angles of a triangle are equal, then their two opposite sides are also equal. So this is PC is A upon root 2, therefore AP is also A upon root 2. So we don't have to do this, but still for better understanding I have shown you how to find the other side if two sides are given in a right angle triangle using Pythagoras theorem. Okay. So these are the informations we have got in a right triangle whose base angle is 45 degree. Now we have to find the value of sine 45. So sine 45, sine theta means perpendicular upon hypotenuse, that is AP upon AC. So perpendicular is A upon root 2 and hypotenuse is A. So by calculation we will get sine 45 equals to 1 upon root 2 cos 45 degree. Cos 45 equals to base upon hypotenuse. So base is PC and hypotenuse is AC. So PC is also A upon root 2 and AC is A, therefore value of cos 45 is also 1 upon root 2. So sin 45 is equals to 1 upon root 2, cos 45 equals to 1 upon root 2. Now tan 45 is equals to perpendicular upon base, that is AP upon PC. As we know that AP and PC are equal, so they will be cancelled and we will get value as 1. Or if you want to put the values, so A upon root 2 divided by A upon root 2, both are equal quantities, so it is 1. So tan 45 is equals to 1. Understood? So we have learned how to find the values of sin 45, cos 45 and tan 45. Okay, hope you will be able to do it by yourself next time when you will try to do so. Okay, now let us go for finding the values of sin 0, cos 0 and tan 0. Now this is a right angle triangle, ABC right angle triangle, where angle B is the right angle 90 degree, AB is the perpendicular, BC is the base and AC is the hypotenuse. Suppose this is angle theta. Therefore sin theta is equals to AB upon AC, that is perpendicular upon hypotenuse. Now we have to find the value of sin 0 degree. What will happen if theta becomes 0 degree? So if theta becomes 0 degree, means this point A will coincide with B. That means suppose this angle is decreased slowly. Suppose the point A is here. Then angle will be reduced. Now let the point be here, A2. If we join this with C, again you can see that the value of theta is decreasing. So if we go on decreasing the height, that is the point A is moving towards B, so slowly and slowly the value of theta is decreasing also. Now as this point A comes closer to B, suppose here, the value of theta will also become closer to 0 degree. So in this way, if we go on reducing the height of the triangle, that is A is moving towards B, a time will come when theta will become 0, and in that case when theta will become 0, the point A will just touch the point B. In other words, the height of the triangle will become 0. Understood? When this theta, this was originally theta, so as we reduce the value of theta, the height of the triangle will also reduce, and at a time will come when theta will become 0 degree, the height of the triangle will become 0, as the point A will coincide with the point B. So in that case the height will become 0. So at theta equals to 0, AB will be 0. Okay, the length of AB will become 0. Now, so what is sin 0 degree? Sin 0 degree, sin means perpendicular by hypotenuse, that is AB upon AC. Now what is AB? AB is 0. So 0 upon AC. Whatever is the length of the hypotenuse, but since the value of AB is 0, 0 upon any value is 0. Understood? Okay. cos 0 degree. Now when this point A coincide with B, in that case AC and BC will become equal. When A will come and it coincides with B, then this will be, the same point will be represented by A as well as B. So here we can see from the diagram that AC, the hypotenuse, is now equals to BC, the base. So what is cos 0? Cos means the base upon hypotenuse, that is BC upon AC. And since BC and AC both are equal, as I have shown you in the diagram, that A coincide with B, so in that case AC and BC becomes equal. So since BC and AC become equal, therefore we will get cos 0 equals to 1. Understood? Now tan 0 degree. Tan 0, again same thing here. Tan means perpendicular by base. Perpendicular is AB, which is now equal to 0, and BC is the base. So 0 upon any value, whatever is the value of BC, but the numerator is 0, so 0 upon any value is 0. Therefore we have got the value of tan 0 as 0. So here sin 0 equals to 0, sin 0 degree equals to 0, cos 0 degree equals to 1, and tan 0 degree is equals to 0. Understood? So we can calculate the value of sin 0, cos 0 and tan 0 in this way. Understood? Okay. Now let us find the value of 90 degrees. Trigonometric ratios of 90 degrees, that is sin 90, cos 90 and tan 90. Now see here, as we now know how to find the value of sin 0, cos 0 and tan 0, so we can easily calculate the value of their reciprocal, that is cosec 0 is the reciprocal of sin 0, sec 0 is the reciprocal of cos 0, and tan 0 is the cot 0 is the reciprocal of tan 0. So since we know the value of sin 0, cos 0 and tan 0, we can also show the values of cosec 0, sec 0 and tan 0. Understood? So here if sin 0 is 0, then cosec 0 will be the reciprocal of 0. So cosec 0 is the reciprocal of sin 0, that is 1 upon 0, that is undefined. Cos 0 is 1, so sec 0 is also 1, reciprocal of 1 is 1, and cot 0 is the reciprocal of tan 0, so tan 0 is 0, therefore cot 0 degree will be 1 upon 0, so this is also undefined. Okay, now let us find the values of sin 90, cos 90 and tan 90. So again let me draw one triangle. A right angle triangle ABC, where B is the right angle. Okay. Now when this is theta, the base angle is theta. So what will happen when theta becomes 90 degree? Just see this. Let us consider this point C. If C moves towards B, then slowly the value of this angle will increase. Suppose C moves towards B and comes here. C is now here, C1. So you can see from the figure that this angle is increased. Okay, the C1 angle A C1B is increased, that is theta is increasing. So if C move further towards B, then the value of theta will increase a little bit more, and in this way, as much as C move towards B, the value of theta will go on increasing, and a time will come when C just coincide with B, the angle C will become 90 degree. So when angle C becomes 90 degree, C coincides with B. When theta becomes 90 degree, C coincides with B. That means C and B are the same point. Here I am writing C. Okay, so C and B becomes the same point, or same point. So in that case, we can write BC is equals to 0, because C and B are coinciding to a single point. So length of BC will become 0. And what will happen to AC? This AC, since C is coinciding with B, then AB and AC will become equal. AB is equals to AC. Understood from the diagram? So when C is coinciding with B, angle theta becomes 90 degree. In that case, the base becomes 0 and the perpendicular and hypotenuse become equal. So cos 90, first of all, sin 90 degree. So here theta is 90 degree because C and B are coinciding with each other. So theta becomes 90 degree. Now what is sin theta? Sin 90. So sin theta is perpendicular upon hypotenuse. Perpendicular is AB and hypotenuse is AC. But both these are equal in length. AB and AC are now equal in length. So AB upon AC becomes 1. Cos 90 degree. Cos is base upon hypotenuse. Base is BC, hypotenuse is AC. So here BC is 0. Therefore 0 upon AC means 0. So cos 90 is 0. And tan 90. Tan is perpendicular upon the base. Perpendicular is AB and base is BC. So AB upon what is BC? BC is 0. So AB upon BC. Now we all know that if 0 is there in the denominator, then the value becomes undefined. So here AB upon 0 will be undefined. So we have got the values of sin 90 degree as 1, cos 90 degree as 0 and tan 90 degree as undefined. Okay. So we can find the reciprocal also, that is cosec 90. If sin 90 is 1, then cosec 90 is 1 upon 1, that is 1. Reciprocal of sin 90. Sec 90. Sec 90 is the reciprocal of cos 90. So sec 90 will be 1 upon 0, that is undefined. And tan 90, so cot 90 is the reciprocal of tan 90. So tan 90 is undefined, then cot 90 will be 1 upon undefined, that is 0 upon AB. So 0 upon AB will be 0. So cosec 90 is 1, sec 90 is undefined, and cot 90 is 0. Understood? So in this way we can calculate the values of all the standard angle for sin theta, cos theta and tan theta, as well as the reciprocal, that is cosec theta, sec theta and cot theta. Hope you have understood the whole session. The whole thing is clear to you, how to find the values of trigonometric ratios of particular angle geometrically. Means we have to draw a triangle and use the concept of sin theta, that is perpendicular upon hypotenuse, cos theta, that is base upon hypotenuse, and tan theta equals to base upon perpendicular upon base. So in this way we can calculate the values of all the trigonometric ratios of these standard angles. So hope you have understood the whole thing. Now you try to do it yourself, all these things which we have learned in the last two sessions, this session and the previous session, where we have learned how to find the values of all the trigonometric ratios of particular angles: 0 degree, 30 degree, 45 degrees, 60 degrees and 90 degrees. Okay, so let us meet in the next class with few problems based on these particular angle, trigonometric ratios of particular angle. Till then, goodbye and have a nice day.